Hello everyone, I'm Siddharthan. In this video, let's discuss how we can build a document question answering system with GPT-4o using LangChain library in Python. So here we will be using the framework of RAG or Retrieval Augmented Generation, where instead of the LLM answering from the corpus of data it has been trained on, it's going to answer from the custom data that we are going to provide it. So in this case, we will pass a document, a process document to the LLM, which is GPT-4o in this case, and it will look at the data or the text present in that document, and it will answer our questions. So this is how RAG works. So let's get started. So I have my Google Collaboratory, and you can just work with CPU environment itself, as we are going to call the GPT-4o API. And if you want, you can use the GPU version as well in order to load your embedding model. And these are the libraries that we need. So we have this transformers and sentence transformer, which provides us the vector embedding model from Hugging Face. And then we have the LangChain and LangChain community libraries in order to access the retrieval chains and other stuffs that we have. And then LangChain OpenAI, which is another extension of LangChain to interact with OpenAI models like GPT-3 or GPT-4. And then FAISS. So this is Facebook AI similarity search. So this particular tool is developed by Facebook AI research team, which is used for similarity search of vector embeddings. And then we have this unstructured and unstructured PDF versions in order to read our data and extract the text from it. So these are the libraries that we need, and I have already installed this library. So if you're trying this out, please install these libraries first. As you can see, it's already installed. So once you install all these libraries, you have to restart the session and you will get a warning message in collapse. So you can restart the session and you can just run this again, and you will see this message of requirement already satisfied. So I'll hide this inputs for now. So let's import the required libraries, and I'll also explain you what's the purpose of all these different libraries and where exactly we are going to use it. So first I'll import OS. So this is used in order to save the OpenAI API key in the environment variable so that we can call the GPT-4o model. And then from LangChain dot OpenAI, sorry, LangChain underscore OpenAI, I'm going to import chat OpenAI. So pay attention to the uppercase and the lowercase letters. So this is used in order to load the GPT-4o model. Okay, so this is the first step. Next is from LangChain dot document loaders. So you can use PyPDF. So in this case, I'm going to use unstructured file loader. So this will be used in order to read our PDF file and extract the contents from it. And then from LangChain underscore community dot vector store, import FAISS. So in case you are using a CPU environment, you have to install FAISS CPU. If you are using a GPU environment or a session, you can use or install FAIS GPU. So that's one thing to remember. So the next step is importing from LangChain dot embeddings, import Hugging Face embeddings. I'll explain you the purpose of all these functions and the modules that we are importing once we complete this. And then from LangChain dot text splitter, import character text splitter. And finally, we need from LangChain dot chains, import Retrieval QA. So in case you don't understand the process of RAG I've already made a detailed video on how this RAG works and the concept of this retrieval augmented generation. I'll give the link of that video in this video description. You can check that out to understand the concepts of RAG. So now let's understand the purpose of like all the functions that we have imported. So as I said, we are importing this OS module. So we need this in order to store our OpenAI API key so that we can call the model. So the next thing is chat OpenAI, which is the function where we will pass the model that we want from OpenAI. So in this case, we'll be using a GPT-4o model. And then we have this document loaders, and in that I'm importing this unstructured file loader. And from LangChain community.vector stores, I'm importing this FAISS. So this is used in order to do a similarity search of vector. So how this RAG works is, right, so let's say we have a document. So we split this document into smaller chunks and store it in a vector DB. So in this case, instead of vector DB, we will just create a knowledge base, which is like kind of this vector knowledge base in runtime. So instead of creating a DB, we are going to use it. And now you have this document stored as vector embeddings. And now the user asks a question that, you know, based on this document. So now we would embed this question as well. So now you have one vector, one question vector, and a larger vector of the entire text. So using this FAISS or the similarity search algorithm, we are going to find the relevant answer for the user's question in the vector embeddings and return the output for that. So this output will be sent to the LLM, and the LLM would kind of properly curate this answer from the question and the answer, and it would give you a response. So this is how this works. That's the purpose of FAISS, which is basically a vector embeddings similarity search. And from LangChain.embeddings, we are importing this Hugging Face embeddings, using which we can import the vector embedding models. So this would take a particular sentence or a text, and they would convert it into vector embeddings. And for that, we need the sentence transformer libraries. So you can use the default Hugging Face embeddings, or you can also, if you think that you can use a better embedding model, so you can choose the one that's present in Hugging Face as well. And then we have this text splitter. So this is used in order to split your larger document into smaller chunks of data. So this is important when you are working with a very large document, or the LLM that you are using has a limitation on how many tokens that you can pass. So that's the purpose of using this. And then from LangChain.chains, I'm using this Retrieval QA. So LangChain supports a lot of chains. So you have this Retrieval QA, which is mainly for retrieving the, you know, relevant information from your vector embeddings or your like document, and then passing it to the LLM and getting an answer. So that's about this Retrieval QA. And you also have this conversational chain QA, which also you know, is used to build a chatbot kind of a thing, where the LLM can understand the history of the conversation and answer based on that. And then you have this graph db based retrieval chains and so on. So for the simple use case of document question answering, we can just go with this Retrieval QA. So I'll run these you know, import stage branch. So the next step is getting the API key and storing it in the environment variables. So I'll say os.environ, and the API key variable should be OpenAI underscore API key. So this shouldn't change. So you shouldn't change the, you know, key name for this. So it should be OpenAI API key in uppercase letters. So this is basically used to save this to environment variables. And when we load our GPT-4o model using this chat OpenAI, it will look for the API key in this environment variable name. So we are doing that. So here we can pass our API key. So I'll go to OpenAI and go to this products, and within this products we have API login, and from there you can create a API key. And I've noticed that for using GPT-4 and 4o, it's asking for the payment method for some card details. So you can give that, but if you don't want to give that, you can just you know, go with the GPT-3 or 3.5 model. So that should also work. So you don't have to change much of the code. So it's like pretty much similar to it. So I'll open the API, and in the left navigation bar, you will see this API key. And this is the key that I've already created. So I can just delete this or revoke this key and create a new one and use this. And I'll name this as doc QA rack. So project, you can leave this as default project, or choose a different project if you are created like multiples. So here I'll copy the API key and put it here. So this is actually not a recommended way to put your API key in your code just explicitly. Instead, you can just put this key in a config.json file or a .env file and load it. So that's like a more recommended approach, so that your API keys and secrets are not visible in your code. So I'll run this. Just for simplicity of demonstration, I'm just putting it, but please don't follow this particular approach. The other videos have shown you how you can do this with the config.json file. So you would put this in a JSON file, read that into a dictionary, and from there you can pass it to the environment variable. So now I'll create a variable called as LLM, where I'll be storing this LLM model. So I'll say chat OpenAI, and within this we have this parameter called as model. I'll say model is equal to GPT-4o. So if you want 3.5 turbo also you can choose that. So but I'll use the newest model GPT-4o, put that in quotes. And the next parameter that I'm going to use is temperature. So temperature determines how random your answer would be. So if you give the value, so this value ranges between 0 and 1. If the value is closer to 0, then if you ask a similar question or the same question, it would give you the same response. If the value is closer to 1, it's going to give you a response, different response for the same questions. So that's about it. So I load this, and again you have different parameters. You can check like the other parameters and play around with that. I'll run this. So this will load the GPT-4o model into the variable called as LLM. So yeah, if you don't save this API key in the environment variable, so this line of code won't work. And then next step is reading the file. So for this I'm going to use a PDF file, a paper on attention is all you need. So this is the paper that first talked about transformer, which is released by Google. So let's upload this document and ask questions from this one. So I'll open this files and upload the PDF file that I have. So this attention is all you need. So you can find this paper online. You can check that out. Just go to Google and search this paper name. Attention is all you need, and you can download the PDF from there, or even you can use like any other PDFs of your choice. So here I'll say load the downloaded document. I'll create a variable called as loader, and this loader is equal to unstructured file loader. File loader. And within this we have to paste the path of the PDF that we have uploaded here. So copy this path and paste it here, and say loader, documents is equal to loader.load, and run this. So this part basically takes in the PDF that we have given here, and it will load it and basically extract like all the text that we have. So the next step is splitting it into chunks. So I'll maybe put a comment here as saying create text chunks, and text splitter is equal to character text splitter that we have imported previously. So here we are creating an instance of this character text splitter and storing it in this text splitter variable, and within this we have to pass some parameter. So here let's say separator is equal to, let's say, new line \n, and here we can mention chunk size. So for chunk size I'll say is equal to 1000, and overlap is 200. Okay, so this should be \n. So let's understand this. So we are creating the instance of character text splitter with separator of this new line thing. So what this will do is this will like look at this document and split the text with this like new line character. So wherever it sees this new line character, it will stop that and create a chunk there. And you can also specify what's the maximum size of the chunk. So here we are saying that the maximum chunk size should be 1000 characters, and the chunk overlap. So chunk overlap is 200. So this is basically when you have two, let's say, paragraphs or two chunks, we can't split it like with some hard constraints. So there has to be some overlap. So let's say that you have a 10-line paragraph and you have to split it into two chunks. So you can't directly say that I'm going to chunk first 5 lines and the next 5 lines. So when you do that, right, so you miss the context in between. So in order to avoid that, we would be having this overlap. So let's say that in this 10 paragraph thing, the 6 lines can be in one chunk and another the last 6 lines can be in one chunk. So there is like some overlap, so that the model LLM or even this vector similarity search that we do is kind of understanding the context in which a particular chunk starts and ends. So that's the purpose of choosing this chunk size and chunk overlap. You can play around with this number too, so check with different chunk sizes if it's applicable for your document and so on. And next I'll create a variable and call this as text chunks, and this text chunks is equal to text splitter dot split documents, and within that we are going to pass the documents, which is nothing but the text that we have extracted over here. So there is a different thing called as split text. So in that case, right, so instead of this will be as a document type. So if I check this type over here, so this will say it's like kind of a document type in this LangChain. So let me put this first thing within this list. So LangChain core documents based document. So in this case, we are using this split documents. So if this is like as a complete string text, in that case, you can use split text. So all these chunks that kind of chunked with this size and this overlap will be stored individually in this text chunks. So let's run this. Okay. So now I'll say embeddings is equal to Hugging Face embeddings. And here I can just mention this without any model. So this will load the default model, but you want a better model, a larger model, you can choose something like this. So you can find that in the sentence transformer documentation as well. So here I'll just go with the default embedding. So you can also go with OpenAI's embedding model, but that would again cost you some usage charges. In order to avoid that, I'm just going with Hugging Face embedding, so where you won't be you won't have to kind of pay anything. So that's the reason. Next, let's create a variable called as knowledge base, and this knowledge base is equal to FAIS that we have imported from documents, text chunks, and embeddings. So this part of the code is to take in the text chunks that we have and convert those into vector embeddings. So that later when a user asks a question, we can embed that question as well and find the comparison between those vector embeddings and the question and retrieve like whatever relevant information present in that particular document. So first we are loading this embedding model and converting this text chunks into vector embeddings by using this FAIS dot from documents and passing the text chunks as well as the embedding model. So this FAIS from documents expects these two parameters. One is the text chunks and the other one is the embedding model itself. So let's call this as loading the vector embedding model. And the next step is vector embedding for text chunks. So this is the step that we have done over here. So let's run this. So this will load the embeddings model. So this may take like a couple of minutes as it has to download the model and kind of it has to load it here, so you can see it. So if you are probably using GPU, right, so you would install the FAIS's GPU version and the model will be loaded in the GPU. So now it's going to load in the CPU this RAM. So instead, if you have GPU environment, it will be loading getting loaded in the GPU. So here you can see the size of the model, which is about like 438 MB. So the next thing that we need to set up here is the chain that we are going to use. Chain for QA retrieval. So here let the model, okay, so as we can see the model is kind of loaded now. So here I'm going to say QA chain is equal to retrieval QA. So here we have different kind of chains as I said earlier. So we have this retrieval QA, which is solely for extracting like this question and answers. You have this graph question answer thing and conversation based chains and so on. So here we can use this simple retrieval.qa dot from chain type, and then we can say LLM So we have to pass the LLM that we have loaded and say retriever is equal to knowledge base dot as retriever. So we can remove the chain type, so it's maybe not needed in this case. Okay, so knowledge base is the vector embeddings that we have over here. Let's run this. So this is our QA chain, and we will invoke this QA chain and ask the questions. Let's just go through what we have done so far. So first we are setting this API key in the environment variables and loading the GPT-4o model using chat OpenAI that we have imported from LangChain. Then we are reading the PDF file and getting the text that's present in this PDF file and saving it in the variable called as documents. Then we are creating the chunks for this document. As let's say the document is like pretty large, we have to create the chunks. So here the chunk size is 1000 and the overlap size is 200. So once we have created the chunks, it's stored in this variable called as text chunks. Now we have to convert these text into vector embeddings. So we are loading this Hugging Face embedding model, and from documents we are converting this into vector embeddings using this model and storing it in this knowledge base. So this is similar to putting the data in a vector DB and querying it in the vector DB. So instead of setting up the DB, we're just doing it in the runtime here with this knowledge base thing, and then I'm setting up the chain as retrieval QA, which is used to retrieve this answers for the question with this FASS and the LLM. So here we are passing the LLM and the retriever as knowledge based dot retriever. So what this will do is when the user asks the question, this chain handles the part of converting this question into a vector embedding, putting that to the knowledge base, getting the relevant information. So once you get the answer, once you have the user's question and the documents part where the answer is probably present, it's going to take those two and pass it to the LLM and get a response. So this is how this RAG framework works. And now we can ask some questions. So here we currently have this attention is all you need paper, right? So here I'll maybe create a question and I'll say, what is this document about? Let's see if the model is able to answer this thing. And I'll say response is equal to QA underscore chain, the chain that we have created, dot invoke, and you have to pass this as a dictionary. So create a key called as query, and within that you have to put your question, and question is stored in the variable with same name question. Now we can print the response. So it will be coming as a dictionary. So you can say response of result. So it will be stored here. Let's run this. So the response will also be like pretty quick. It won't take like a long time in order to give you the response. So here you can say this document is a research paper titled Attention is All You Need, authored by this person, and so on. So you kind of see this response over here. So if you want to see this exact output, right, you can just say response and you will see that here. So you have the query that you have asked and the result actually contains the response that is coming from the model. So this is what we need. So you can just say something like, I can ask like specific questions from there. So I have curated like another question that I can ask. So here I'll say, what is the model architecture discussed in this paper? So it has to answer the question from here. And I'll say response, same thing. Response is equal to QA chain invoke query question print. So instead of print, in order to put all this thing here, I'll just say response of result. So I don't want to scroll through the answer. So let's see. So we get this model architecture discussed in the paper is transformer. It's a novel network architecture and so on. So we get this response. So we also we have to make sure that the response is coming from the paper. So what I'll do is open this paper that I have. So attention is all you need. So I'll open this PDF. I have this thing. So I've tested this out. So we have this applications of attention in our model, right? So let's run this particular question and make sure that the model is answering like whatever is present within this particular text. So I'll come back here, copy this first maybe, and here let me put this as question is equal to what are the applications of attention in our model. So let's ask this particular question and just copy this response thing. So we are getting it. We will try printing this output. So we have this encoder, decoder, attention, self-attention in the encoder, self-attention in the decoder. So in 3 layers, the queries come from the pre-as decode layer. So this is pretty much like what's present over here. So this is how we can pass a document to the LLM using this vector DB, vector embeddings and so on, and get a response from it. So I hope you understood everything present over here. I'll just give you a quick recap of whatever we have done. So the first step is installing all the required libraries that we have, such as transformers and sentence transformer, used to load the embedding model, LangChain and LangChain community, and LangChain OpenAI to load the model, as well as just to work with this change that's present in LangChain, as well as like all the unstructured FAIS. So all this we are importing from the LangChain's extensions. And then we have this FAIS CPU, which is also required, an unstructured and unstructured PDF in order to read the PDF file and extract the text from it. So here we are getting this API key from OpenAI and storing this in the environment variable. So the next part is loading the LLM GPT-4o model using this chat OpenAI from LangChain OpenAI, reading the file using this unstructured file loader. And once we done that, we are splitting this document using character text splitter. So you also have this another type of text splitter like called as recursive text splitter. You can try that as well. So then we are chunking the document's text into different text chunks, and then converting those chunks into vector embeddings using the embedding model that we got from this Hugging Face embedding. So it's getting downloaded over here, and then we are creating a chain, which is really important. So we in this case we are using a retrieval QA, and then we are passing the LLM and like how the retriever needs to be. So in there, as I said, the different chains takes different parameters. So the conversational chain takes the chat history as another parameter, so that it knows like whatever the LLM has answered before. And finally, we can ask a question and get a response from it. So I hope everyone is clear until this point. So please practice this code. So this actually is like a very simple approach of doing this. And maybe in the next video, let's build a Streamlit user interface for this and work with the different models. So the user can select different models and get a response for a document. So yeah, I'll see you in the next upload. Thanks for watching.